Hello, Coach Travis here with another calculus video. This is a video about Newton's method, and in particular it's a video about how sometimes Newton's method doesn't quite work the way you hope it would. So the question here is we've got if Newton's method is used to find the root of r of x is equal to 2 to the 1/7 power, which is to me the same thing as 2 times the 7th root of x. So what we got here, I've used GeoGebra to draw a graph of that, and here's the equation. You can ignore those other two functions. Those are just functions that are hanging around from another problem I was doing. Actually, it occurs to me now that we're doing this problem, this is kind of a dumb problem, because really, if I want to find the root, it's at 0. I mean, everybody knows it's at 0. You can use algebra to find that the root is at 0. So this is kind of just an academic question to illustrate that sometimes you do have to be careful with Newton's method, because it can fail sometimes. So for practical purposes, this is a ridiculous question, because you would never use Newton's method to find the x-intercept of this function, because it's obvious. Or it's not as obvious. Well, it is obvious, but you don't need Newton's method. You can just use algebra. But it's interesting to still apply Newton's method and see, because you can kind of see that, okay, something can go wrong, and it's potential that that thing could go wrong in a more complicated situation as well. All right, so anyway, so let's do it. So okay, so it says we're going to start with a guess of 1. All right, so great. So the way Newton's method works is, okay, I put 1 into the function. So if you put 1 into the function, you get 2 out. And then what we do is we draw the tangent line. We draw the tangent line at that point, and we see where the tangent line intersects the x-axis. So it intersects the x-axis at -6. Okay, great. So then what you do is you put -6 into the function. So all right, so if I put -6 into the function I'm interested in, then I get another point on the function, and then I'm going to draw the tangent line at that point. And so now, and now I'm like, way out, and then I want to look for, well, where does that intersect the x-axis? And it intersects the x-axis way out here at 36. And now what's supposed to happen is these intersection points. These are supposed to get closer to the actual x-intercept. So that is our first guess. Our first guess was 1. And then what Newton's method told us is an improved approximation would be -6. And then Newton's method is saying, okay, a more improved approximation is 36. But that's ridiculous, because we know the x-intercept is near 0. And so, in fact, the x-intercept is 0. And what Newton's method is doing is it's giving us guesses that are getting farther away from 0. I mean, we started with a guess of 1. I mean, that was our initial guess. And Newton's so-called improved guess was -6, which was actually worse. So what we got here is Newton's method is exploding on us here. So what is the right thing here? Yeah, Newton's method will not work because the values are diverging. Diverging means getting farther apart. And that's what's going to happen. If you keep doing this procedure, you're just going to get numbers that are farther and farther away from that x-intercept.